Good day, friends. I am Mr. Kelvin, and welcome to my channel. So today I have a question on energy, and I want us to solve together. The question says, a student hangs a weight on a Newton meter. The energy now stored in the spring in a Newton meter is 4.5 times 10 to the power of minus 2 joule. The student then increases the weight on a Newton meter by 2.0 Newton. Calculate the total extension of the spring. The spring constant is 400 Newton per meter. So first thing, when you see a question like this, you write out the parameters given to you. The energy was given as 4.5 times 10 to the power of minus 2 joule. They said the student then increases the weight on a Newton meter. So when the student increases the weight was increases the weight by 2.0 Newton, and the spring constant was also given as 400 Newton per meter. So first thing first, let's solve for the extension that will cause an energy of 4.5 times 10 to the power of minus 2. You know, if you look at your equation sheet, you see the equation E is equal to half KE squared. This is the equation for the elastic potential energy, where K in the equation is the spring constant, then E is the extension. Now you're solving for E. E was not given, so if we make E subject to formula in this equation, becomes E equal to the square root of 2 capital E divided by K. So this is what we use in solving. So E is equal to the square root of 2 multiplied by the energy, which is 4.5 times 10 to the power of minus 2. So when you solve this, you punch this in your calculator, that's divided by the spring constant. You punch this in your calculator, you get an answer of 0.015 meter. So this is the extension. So when the spring was extended by 0.015 meter, it causes an energy of 4.5 times 10 to the power of minus 2. So let's solve for the force that will cause this extension. The force from Hooke's law, F is equal to KE. So from Hooke's law, the force here, the spring constant is 400, and the extension is 0.015. So if you punch this in your calculator, 400 multiplied by 0.015, let me quickly do that on my calculator. Okay, 400 multiplied by 0.015 is 6. So this is the force that causes an extension of 0.015. And when this force was applied, an energy stored of 4.5 times 10 to the power of minus 2 was in the string. So when this force was increased by 2, so the increase in the force is going to be 2 plus 6. So it was increased by 2. He said we should find the extension. So 2.6 is 8. So when it is increased by 2, the force becomes 8. And what extension will this 8 Newton cause on the string? So we go on to the same equation, F is equal to KE, where the force now becomes 8. The spring constant is 400. The extension now is unknown. So we use this to solve for the extension. E is equal to 8 divided by 400. I'll quickly point this on my calculator. So the extension now becomes 0.02 meter. So this is the value we are asked to solve for. I hope this is easy. So you can just give this a try. Give this question a try after looking at how I solved the previous one, then drop your answer in the comment section. Thank you.